Hello, welcome to the session 6 on laser basics. In this session, these are the various objectives. It is about the applications of lasers. I have listed 5 important areas in which lasers are used. The first one is medical applications, in which it is used for surgery, scar removal, and also for other cosmetic applications, and it is also used for angioplasty. Then second is industrial applications, in which it is used for cutting, drilling, welding, etc., and it is also used for isotope separation. It is used in defense. One example is LIDAR, which is the light detection and ranging, and it is also used for various research applications. There is an extensive research work going on all around the world in the field of optoelectronics, and it is used for holography. It is used for nonlinear optics, in which this laser can be used for studying and measuring various properties of materials, and it is also used in your daily life, like for example in printers, barcode readers. It is used for data writing. It is also used for recreational purposes, for example the laser light show, music systems, etc. So first we will see the medical application, in which I have taken a specific example in which laser is used for eye surgery, and these are the various steps involved in a particular procedure called LASIK. LASIK is used for correcting the curvature in the cornea, the defect of which will lead to a short sight or long sight. So to begin with, the eye into the eye, as usual in any surgical procedure, and anesthesia will be used, but here very locally and on a very small area the surgery is performed. So just one drop of this topical anesthesia will be sufficient, and after giving it, the second stage is to use a laser which we call the femtosecond laser. That laser is used to create a small opening in the cornea. So you can see for example, if you examine the third diagram, you can see a circular shaped cut is made on the top of the cornea, and a flap like structure, flap like opening has been made, and it is open like a book. And this is a small area on top of the cornea, and that is cut using a laser, which is normally a femtosecond laser. You don't have to learn femtosecond laser, but for the moment you understand that it is a laser which is used for eye surgery, and it is a laser, and from the femtosecond laser it is the UV light which is used here, because it does not destroy the surrounding tissues, and it doesn't make a lot of heating effect, so that it will not it is within the tolerable limit of the human tissue. So after that type of a cut is made, this top portion is opened, so that doctors will get access to the eye, so that after that whatever correction is to be done, depending on the requirement of the patient, some corrective surgery will be done. And normally for the corrective surgery, for example if it is long sight or short sight, the correction should be done on the curvature of the cornea. Either you will have to make it flattened or you will have to make it steeper. So that type of a procedure will be done using another laser, and that is normally the excimer laser. So excimer laser is also considered to be a cool laser. It will be emitting the UV light, and that will be capable of working below 65 degrees Celsius. So that is also not harmful to the human tissues. So that kind of a surgical procedure will be done using another laser. Or there can be, in some situations, if it is a cataract operation, it is the lens which is to be corrected. So in the case of cataract, the lens would have become opaque. So if it is too severe, that lens should be removed and it will be replaced by an artificial lens. Or it is also possible if it is some kind of an opaque structure on the lens, over the lens, that can be removed using another laser. So whatever be the surgical procedure required, it will be done, and after that, at the fourth stage, this flap which is open, it will be positioned back, and in this case it will be just put back into place, and it will undergo natural healing. So this is an advantage of this kind of a surgery. The cut that is made, which is the third diagram on top, in which there is no numbering is given because it is an actual photograph. So when a cut is made using a laser, the cut is actually very precise, so that after the surgery, when you put this flap back into position, it does not require stitching. So this will heal on its own, because it will be naturally joining with the remaining tissues, and the healing procedure will be faster. And all the surgical procedure where a laser is used is referred to as bloodless surgery, because first thing is that the cut is very precise, so that the loss of blood will be minimum, and moreover, it does not because of this if, for example, if it is a UV laser or these kind of a lasers, it will produce a little bit of heat, so that heat will be harmful to the, it will not help any kind of infection on the area where the surgery has been performed. So when there is no infection, the healing time required will be very small, so that will also lead to a less loss of blood. So on the whole, all these surgical procedure using laser is referred to as bloodless surgery. So here I have described all these steps in the LASIK procedure, which is already explained in the step 1. A cut is made and it is opened, and then in the third diagram you can see a laser is used. So in order to make this cut, one laser will be used, and then cornea is opened, and beneath we can access, and using another laser, whatever correction procedure is to be done, that will be done, and then this flap will be put back into position, and it will undergo natural healing. Now, as I explained earlier, this laser surgery is referred to as bloodless surgery, because the cut is very precise, and that will result in very less bleeding than conventional surgery. So then the operation procedure itself takes very less time, so that the patient doesn't have to spend a lot of time in the hospital. Because of this presence of laser, there is no possibility of germs accumulating on the surgical site, so the recovery time will be very small. So all these will make this type of a procedure a bloodless surgery. Okay, this is just one example that I have taken. You can find out more examples. You can read a lot and find out other examples. For example, other surgical procedure in which lasers are used. So one thing I would like to suggest is you find out, for example, which laser is used for which purpose. For example, for eye surgery, I told you femtosecond laser and excimer laser is used, and for scar removal, what type of laser is used. For hair removal, what type of laser is used. Then laser is also used for dental fixtures, or any procedures on the dental fixtures. So in that case, what type of laser is used. So you can read and find out, and try to remember a couple of names of these lasers which are used for a specific application. So this is another example which I would like to explain to you. This is very important other than this cosmetic application. So this is laser is used nowadays in angioplasty. So I would like to just tell you, before people started using a laser for angioplasty, what kind of angioplasty was done. Angioplasty is the procedure which is used for removing the fat deposited inside the blood vessels. So earlier, before a laser was used in these type of operations, another procedure was done, and that is referred to as this balloon angioplasty. So you can see in this diagram, the first picture, these two are the blood vessels in which there is a clot, fat deposit. So in the first diagram, you can see there is a structure which is a catheter has been inserted into that region, and it contains a small balloon like structure. So it will be adjusted in such a way that this balloon will come in between this region where the fat has been deposited, and then this balloon will be expanded. So on expansion, that balloon will remove this fat deposited on the inner walls of this blood vessel. So this is balloon angioplasty, whereas the same thing can be done using laser. And in this case also, an excimer laser is used because it's a cool laser. As I told you, it can operate at 65 degrees Celsius, so it will not damage the inner tissues inside the blood vessels. So this laser is used in angioplasty. And this is an example. This is just some picture which describes how this angioplasty is done using lasers. So into this blood vessel, an optical fiber has been inserted, and that fiber will carry the laser light which should be used for treating this abnormality. And it also contains a camera, so that it will give us it will project on a screen whatever is inside, or whichever path along which it is proceeding, it will project that into the screen because of the presence of the camera. So the doctors will be able to identify the location where this plaque has been deposited. So when this optical fiber reaches the location, the laser will be turned on, and that laser will be hitting this plaque, which is actually the fat deposited, and it will absorb this laser light. And how this is removed is this absorbed light will generate heat, and it will burn this plaque deposited. So you can see that in the bottom image, that the laser light is being absorbed by this material, and it has been burnt, and it is crushed into small pieces, and it falls into the bloodstream. And when it falls into the bloodstream, it is like a extra body, a foreign body, and that type of particles will be naturally removed from our body through this flushing out mechanism of the blood flow. So here I have shown you a link, which you can follow that link, and it shows an animated video in which this laser angioplasty, that procedure, you can see it more clearly. So this is industrial application of laser, and the most the three important things that is using laser in industry is cutting, drilling, and welding. So cutting, drilling, and welding normally done on heavy metallic plates or on epoxy plastic. So in that case also, but here I have shown you an image in which some material processing is done on a metallic piece. So all these applications, cutting, drilling, and welding, they are referred to as the material processing applications in industry. So in the case of cutting and drilling, the procedure or the idea is essentially the same. For example, you can see a laser head which is focused onto a metallic plate. You can see there is a lot of spark generated, and this is used for drilling a hole inside this metal. And this spark that you can see, it is actually not the laser light. Normally invisible Infrared lasers will be used for this purpose, and that you cannot see, but this light that you can see here is actually the spark which is generated due to the interaction of this laser with this metal. So how this cutting and drilling is done is, for example, in this picture you can see the laser is focused onto a single spot, and at that spot very high energy laser will be used for this purpose. So the material will absorb the light, and it will undergo evaporation at this location, and on evaporation that material will be removed from that location, and it will result in a hole. And the same is the idea behind using laser for cutting. So you just have to move the laser head like this way along the direction in which you want to make the cut. So both for cutting and drilling, it is the evaporation of the material that is taking place, but depending on the material that you want to cut or drill, you will have to use different types of lasers. For metals and also for bricks or cement, people are using CO2 laser. For example, it is an infrared laser which is emitting light in the wavelength of 10.6 micrometer. Also Nd:YAG laser is used. That is also another infrared laser which is operating at the wavelength 1.06 micrometer. So normally for all these procedures, if it is a metal or a wood, not wood, a brick or something like that, or cement, then for processing those materials, it is the infrared laser which is normally used. Whereas in the bottom image you can see a schematic diagram in which it is illustrated how to use laser for welding. So you have got two beams which you need to fuse together. So the laser beam will be focused, and it will be moved along the sides of these two beams which we want to join together. And in this case you will have to be careful that we should not raise the power levels of this laser should be adjusted, and the exposure time of this laser with the material should be adjusted in such a way that it will just undergo boiling and not evaporation. In the case of cutting and drilling, evaporation should take place, whereas in this case the temperature and the exposure time should be well below the threshold required for evaporation, but it should undergo boiling. So when it boils, what we do is we will remove the laser, and we will bring these two beams close together. We press them together so that it will, on cooling, these two will fuse together. So this is the essential idea behind welding. Here I would like to show you a schematic diagram in which some of these diagrams, at least a smaller version of this diagram, you'll have to learn. So here I have shown a femtosecond laser which is used for material processing, but what type of laser you will use, it depends on what type of material you want to process. So here I have just shown you a femtosecond laser because it is capable of delivering high energy pulses, and that laser is first passing through an attenuator, and that attenuator is actually a device which will reduce the power of the laser which is passing through it. For example, suppose you want to you have this laser structure and you got this whole experimental setup, and suppose you want to use the same experimental setup for processing steel and also for processing epoxy, then the same laser should be used at high power for processing steel, and it should be used at a low power for processing plastic. Okay, so in order to adjust that power depending on the material that we want to process, you will have to use an attenuator. Attenuators are available at various capacities. It can reduce the power level of the laser which is passing through it to a specific ratio. Then we are using a shutter here. Why this shutter is used is because during the operation, during this procedure, we will have to turn off the laser beam or turn on the laser beam, depending on whether we want to do the welding or whether we want to move the laser head to a different location, so that on the way in which it is moved, it should not fall on any object. So sometimes you will have to turn on the laser, sometimes you will have to keep it off. But normally we'll be using very huge lasers, which requires a lot of procedure for turning it on, and it is not advisable to turn off the laser during this procedure. So instead of just turning off the whole laser, what we do is we'll keep a shutter in front of the laser. So whenever we don't want the light beam, for example in the case of welding, you have to melt the material and then you'll have to remove the laser beam, and at that point we don't turn off the laser, but instead we will keep this shutter closed. This shutter can be opened or closed depending on our requirement, and then it passes through a mirror. So we are showing two mirrors here, and the first mirror is reflecting this beam into a microscopic objective. It is a combination of convex lenses which will focus the beam to a very small spot, and at that focal point we will keep the material which we want to process. So that will further increase the energy density of the laser which is heating this material. And a portion of that light is again taken using another mirror. It is deflected and it is sent to a CCD camera which is connected to a computer, and that computer is also connected to some control electronics which is connected to a translation stage. And what this translation stage is doing is you have to move either the laser head you'll have to move, or you'll have to move the material depending on the shape that you want to cut on the material. So this translation stage is an electronically controlled device. It can move along both the XY direction and also up and down direction. So it can move both all the three directions, XY and Z direction. So depending upon the shape that you want to cut, it will either move this laser beam, or in this case it is shown that this material which we want to process, it is kept on this translation stage, so it will be moving the whole material. When the translation stage is moving, the whole material will be moving and the laser head will be stationary. And so this is the basic schematic diagram which is used for these cutting, drilling and welding applications. So here again I have just shown you a photograph. As I told you before, it will be a invisible laser which is normally used, and you can see this is something like the inside part of the CPU of the computers. You can see all these holes. All these are done in exactly the same manner, and is done very fast. And you can see for example, if you examine this hole which is through some magnification device, a microscope for example, you can see the edges of all these cut that is made using laser will be very precise and sharp and clean. And as before, you can see the spark. It is not the laser light which is used, it is actually the spark which is generated due to the interaction of the laser with the metal. And now here also I am showing you a link which you can go and watch. It shows you a very neat video of how this laser is used for cutting, drilling and welding. Now this LIS, which is laser isotope separation, that can also be considered to be another industrial application, because this can be used to separate isotopes like uranium-235 and 238, which is used in nuclear reactors. And the essential idea is that we will be having, when you get uranium from the earth, it will consist of both 238 and 235. So first we will vaporize this uranium mixture, and that vaporized particles will be sent along a stream, and then at one point it will interact with a laser beam. So a laser beam is sent along the path of this vapor, which consists of uranium-235 and 238 gas molecules. And this laser is used in such a way that the energy of this laser or the frequency of these laser photons should be in such a way that it will be absorbed only by the uranium 235 atoms. You can assume that uranium 238 atoms will be having energy levels at a higher spacing, so that it won't be able to absorb that laser. So 235 will absorb the laser, and after absorption it will undergo ionization. One electron will be removed from the outer orbital, so it will become positively charged. So then beyond this laser beam paths, you have got a collection of uranium 238 gas molecules and ions of uranium 235. So then at that point it is very easy for us to separate these two, because one is charged and the other one is not charged. So if you apply an electric field there, these charged particles will be deflected and it will be collected on one side. So this is how laser is used for isotopic separation in nuclear reactors. And this is an example. This is just some picture which describes how this angioplasty is done using lasers. So into this blood vessel, an optical fiber has been inserted, and that fiber will carry the laser light which should be used for treating this abnormality. And it also contains a camera, so that it will give us it will project on a screen whatever is inside, or whichever path along which it is proceeding, it will project that into the screen because of the presence of the camera. So the doctors will be able to identify the location where this plaque has been deposited. So when this optical fiber reaches that location, the laser will be turned on, and that laser will be hitting this plaque, which is actually the fat deposited, and it will absorb this laser light. And how this is removed is this absorbed light will generate heat, and it will burn this plaque deposited. So you can see that in the bottom image, that the laser light is being absorbed by this material, and it has been burnt, and it is crushed into small pieces, and it falls into the bloodstream. And when it falls into the bloodstream, it is like a extra body, a foreign body, and here I show you another picture which shows you which will give you an idea about what a hologram is. Here you can see 3 colored light which is falling onto a black and white stripe, which is like an indifference pattern. So that is actually the hologram. If you record the hologram of an object, it will be like a black and white, some black and white lines will be there, which will be like an indifference pattern, and you will have no idea what that image is there inside. And if you want to see that image, you will have to do another procedure. You will have to illuminate this stripe using a suitable laser, and that will reconstruct the image. For example, here you can see the image of a bird is being reconstructed, and that is the reconstructed image, and that is what we normally see as the holographic image. And the property of this image is that it has got a 3-dimensional property, which means you can view this image from different angles, and it will give you a perspective. The perspective can be different when you view it from different angles. So that is how this holography, that is the difference between conventional photography and the holography. So if you think why this kind of a holographic procedure imparts this 3-dimensional feature to the image which is reconstructed. So in order to understand that, anyway we will learn it later, but here I will just quickly mention some of the important points. Suppose you take a photograph using your camera. Suppose you click a scene, for example your class, you take a photograph of your class. So when you take the photograph, you have got a picture on a 2-dimensional space, and that shows you the people who are sitting at the front row and the people who are sitting at the back row. So you will have no confusion which is the front row and which is the back row, because the intensity of the light, or the people in the front row, they may be looking more brighter than the people who are sitting at the back row. So it is because the when you click a scene, there are different spots in that scene, and each of that spot will be reflecting some light, and that light will travel from the spot and it should fall on the camera. So by the time it reaches the camera, it may lose some intensity. So that is the reason why when it is coming from the front row, it is traveling a smaller distance, so it does not lose any intensity, so that the objects in the front row will appear to be brighter. But so that way you have a clear idea about which is the front row and which is the back row, but we have no idea how much is the separation between these two rows. So that is what is obtained in three-dimensional photography. So if you want to know how much is the separation between the front and back row, you must know how much is the distance traveled by these two light rays reflected from the front row and from the back row. So if you can somehow capture that information also and record it along with the recording of intensity, then you will be able to recreate a three-dimensional image. So when a beam is coming from the front row and also from another beam from the back row, these two beams will be traveling two different distances, and during that time the phase it will acquire will be different. So the light rays, when they are coming from different spots, they are traveling different distances, and it will be carrying different phases. So in addition to the intensity, if you can also record the phase of the light rays which are falling on the recording medium, then you will be able to create a three-dimensional image. So that is the idea behind holography. It is a technique in which both the intensity and the phase of the light will be recorded. That is all what I want to explain today. But this is since it is an always evolving topic, you will have to read a lot and find out other applications. But in your syllabus, it is the industrial application of lasers and the holography which is highlighted as the application of laser. So I suggest you read more and find out about other applications also. Okay.